Let me ask you a question. What do you think a flying baseball, a dropped egg, and the International Space Station all have in common? If you said they're all spelled differently, you're right. But they also share another feature. They are all moving in the same style, guided by the same force. They are examples of what physicists call projectiles. Hello and welcome to today's video. I'm going to introduce you to an especially useful concept in classical physics. It's called projectile motion, and it works like this. A projectile is any object that has only one force acting on it, the force of gravity. Take a moment to think about that definition. It's both precise and profound. Any object that is guided only by the force of gravity is a projectile. Projectile motion, therefore, describes how these things move over time. So, what does projectile motion look like? The simplest case is freefall, something that falls freely downward. Hopefully you already know that gravity draws objects closer together. The planet Earth is one very big object that pulls other objects, people, vehicles, buildings, and so on, toward its center of mass. From our perspective on the Earth's surface, gravity pulls objects into the ground. Before an object impacts with the ground, it is in freefall and it is therefore a projectile. From the perspective of this egg, gravity is the only active force, until it hits the floor. Freefall is what we call one-dimensional projectile motion, because all the movement is in a straight line. However, projectiles can move in 2 dimensions as well. What does that look like? It looks something like this. The object that made this path has some forward momentum that causes it to move to the right. At the same time, the force of gravity is pulling down on it. In this section, the object is actually moving upward, like it's been launched from the ground. Gravity slows it down though, until it is moving toward the ground. Its path is generally called an arc. In mathematical terms, it's a parabola. This kind of path can describe any case of 2-dimensional projectile motion. In other words, any projectile with sideways momentum moves along an arc like this one. For instance, picture a person hitting a baseball. For a split second, there's a contact force caused by his bat pushing the ball, which gives it momentum. But the second that ball loses contact, it's a projectile. Until it hits the ground again, gravity is pulling on it and it moves in an arc due to the momentum the bat gave it. At this point, we need to stop for a moment, because there's some fine print on the basic theory of projectile motion. As you may already have guessed, the theory is a little different from the practice. Here on Earth, we have an atmosphere that provides additional forces like air resistance, and, air for us to breathe. But it's a different environment from the frictionless vacuum where physics formulae seem to be derived. When you hit a baseball, it should follow a perfectly parabolic path. In reality, that path can be changed slightly by factors such as air resistance, which is literally the air resisting the movement of the ball, and crosswinds. How many times have you hit or kicked a ball and noticed it shift sideways because of a gust of wind? There are other forces on Earth that can interfere with perfect projectile motion. Raindrops falling on something apply a slight downward force, or flying insects, or minute ash particles. Even our magnetic field can create minuscule forces in objects made of metal. So, the practice of projectiles is a bit more complicated than the theory I've outlined, but it's not as bad as it sounds. For most projectiles, the effects of these additional forces are so tiny we can ignore them. If we treat gravity as the only active force, we still get that neat parabolic arc. It's only when we're dealing with outrageously large forces or a very slight or small objects that we need to worry about other factors. With that out of the way, let's focus on one more example that is essentially found in a frictionless vacuum. The International Space Station is a satellite that has been hosting astronauts since the year 2000. It's the largest human construction in orbit around the Earth, and it passes over our heads once every 93 minutes. It's also really cool to look at. You can argue that a satellite is a projectile, because literally the only force acting on it is gravity. Satellites are sort of special cases though, since they move in circles rather than arcs. In this case, the circle is centered on Earth, and the space station's momentum is just enough to keep it at the same distance from Earth at all points in its orbit. If that weren't the case, it would either spiral in and become a meteor, or it would leave this orbit and shoot off into deep space. To summarize, a projectile is anything that moves under the influence of gravity and, for practical purposes, no other force. Anything you can drop, throw, or launch fits the bill. Even the water droplets gushing from this fountain are projectiles. You can see the arcs they make as they launched into the air, slowed by gravity and brought back down. Now you have this knowledge, you can investigate more phenomena in physics. Projectile motion leads us into the high-speed field of ballistics, the mathematics of movement and acceleration, and the science behind sports. All those are topics for future videos. For now, I hope you found this introduction helpful, and you're keen to learn more. Thanks very much for watching.